Hello everyone, this class for math elective. So then this topic we're gonna learn about the limits of functions. Everyone know about the functions already. Since you in the previous years you used to learn about the function, find the value of function, right? But in the past, when we find out the value of function, most of the time we gonna just just replace the value of x or domain, and then we get the value of y to get the answer for functions. But now, sometimes function we couldn't find the answer or the solution. So then we have to think about the limits of function by using the limit of function. Can say the key of dealing with the limit of function is more like a dynamic problems. Okay, we did not do like exact and replace the value of x in the function. So what is about now? See the example below here. Okay. So f of x equal to 0.1 x squared. This one, right? Um, when we find out the value of the function, first of all, you can see if we replace x with the 4, right? So from here you can check. You still remember how to get the horizontal asymptote and the vertical asymptote. Everyone still remember last year we learned. Okay. So then the first of all, we see the denominator here, x minus 4. So we know right away, correct? X shouldn't be 4. If x equal to 4, then become undefined. The numerator on the top, we can get some number. But if when you replace x equal to 4 and x on the top here, then you will get some number over 0, correct? So then we're gonna say this is no answer or no solution. That's the way we do in the past, right? Then when you make this problem, then we're gonna think about the limits by using the limits of functions to get the solution or get the value of y. So in this case, uh, uh, see this from this function first. Okay, we're gonna use for the next one. Then we go to when you plot graph. So this one, just see if we plot graph, right? If we plot graph here, okay, we this is a y and the x, okay. So then this one, if we have say x equal to 4, for example 1, 2, 3, 4 here, then we're gonna have the vertical asymptote right away. Okay, so this is gonna be like a vertical asymptote. Okay, we know this one right away. This is a horizontal, vertical asymptote. And vertical asymptote and the horizontal asymptote, we couldn't find it because you see this one x power 4 and this is x power 1. So it doesn't have the horizontal asymptote. Okay, so we have only vertical asymptote, which is this one. X, it shouldn't be equal to 4. Then this will represent asymptote, remember. But when you plot graph the whole thing, so if you want to find y-intercept, x should be 0, right? So you replace 0 and replace 0 on the top here, 0, 1.6 times 0 power 2 and plus 2 plus 0. So from this one gonna be what? Negative 8 over negative 4, that equal to 2. So then you're gonna have when x 0, y gonna be 2, like a 1, 2 here, for example. And then you replace x, right, like a 0.1 or something. Keep approaching. So now, when you approach, when you plot the graph here, at this one gonna be some value, which is open dot. Now we see the next page, maybe can see the graph, how to look like exactly, okay? So now we go this one, second one. Now everyone see this. For this one, okay, for this function, the one we just have, oh, I have to elect this one. Okay, so now this one from the function we have before. Okay, when we plot graph gonna be this one. You see this one, if x 0, right? We have y equal to 2 now. Here, this one is a 2. Okay, but when this one, when x equal to 4 is right here. So you see this one have one open dot here or empty dot. So sometimes we call void, void. So now this is gonna be have like an open dot. Okay, so like when we learn period, you say this one is a vertical asymptote. Okay, so this one gonna be kind of open dot here. When you plot graph, like this one, you keep plotting like this one, right? Gonna be like this, similar like this one. Okay, so this one should be a little bit curved like this. Okay, then this one gonna have open dot. So in this case, you see, we use the idea of limit. That means when x equal to 0 and so on, from the left-hand side, you see, we see this table, maybe more understanding. X approach 4 from the left, like this one from the left. Okay, so this one approach closer and closer to here. So say maybe we can start from 3.9. Okay, 1, 2, 3, some here. 3.9 should be somewhere here, right? Very close. When you replace 3.9 in the x, right? So we have to go back to this formula. I may like the function. This one, this formula, okay? Maybe I write down here f of x equal to 0.1 x power 4 minus 0.8 x power 3 plus 1.6 x power 2 plus 2x minus h over x minus 4. Okay, so we'll come back to this one. Then see, if we replace x equal to 3.9 somewhere here, right? Replace in here 3.9, and this one replace with 3.9, 3.9, this one also 3.9. So when come out, you will get the value of y or f of x 1.8479. And so on, when closer and closer, like a 3.99, we get one, the value of y going to be 1.9841. And very, very close, like a 3.999 from the left. Then now we do from the left, okay, approach to 4. So 3.999, when you replace x in there, will get y equal to 1 here, 1.9984. At the same time, if you replace value of x approach to 4 from the right, from here, okay. For example, if you start from here 4.1, this is 4.1, okay. Okay, 4.1 maybe somewhere here, right? Maybe assume it here. So you will get y equal to 2 point something, it's not clear. And then keep really close, closer and closer, right? When x approach here, closer like a 4.01, you replace x this one again, you're gonna get 2.016. And if you get really, really close, like a 4.001 here, y gonna be 2.0016. So you can see when x approach this one from the left and approach on the right, when approach closer to the x here, the value of y really close to the open dot here, right? But never ever touch, just approach closer and closer to x, to 4, I mean. Okay, So then you see from the left, when you really closer, it's close to 4, like a 3.999, y gonna be 1.984, and from the right gonna be 2.016. So when you approximate this one like a 2, right? And this one also approximate round up become 2. So that means when when x up very close to the up close to 4 from the left and up close to 4 from the right, the value of y gonna be 2 equal to 2. So final equal to 2. Okay, so then from this one, okay, if you say you lay down you from this one, right? If you take limit both sides, f of x when x approach to 4, and this side also lay down limit x approach to 4 when x approach to 4, then this one limit f of x limit of f of x when x approach to 4 will equal to 2. That's the answer. So in previous year, remember just the beginning I say f of x here gonna be we can answer say we couldn't find the solution because this one you can get value of the function every point of on the real number except x equal to 4, right? So in this, if I ask you, if I say f of x when x equal to 4, then what gonna be? So you replace 4 in here, become 4 minus 4, and then 4 replace in here, 4 replace in here, and so then you're gonna answer this one undivided or no solution. Okay, we understand now. So now in this case, one we cannot find out, we can use one we cannot find out the value of y, you can use the limit functions concept, because the idea of approach closer to 1, the value of 1 point of x. Okay, like in this example. Okay, so after this one, I would like to go for the property of limit first. Okay, so now we go next one. Okay, before that should be go now. Once we have this one, we're gonna know the definition of limit. We will understand. We're gonna then we can write the definition of limit. See this one, but this is informal. We're gonna learn formal definition of limit later. But now, from the idea I just explained for this example, okay, so we can see this one. Okay, I have to erase the old one. So now see this, let f be a function. F be a function means this one, okay? This one. And let c be a real numbers, such that c now, this c, it means this c, okay? Mean this one. This 4 is a c. So that when approach to can be approach to any real number, okay? Such that f of x is defined for all value of x near x equal to c. Now, didn't say x equal to c, but they use near, okay? Near x equal to c, except possibly as equal to c, okay? From this definition, when you get the limit, then you see this, the limit of function f of x is x approach to c, is a number L. So this L or this one equal to 2 from this answer. Okay, then we get now, we can write in the pattern of the limit. You can write down limit function f of x when x approach to c equal to L. This is a kind of, can say the pattern or the formula of writing of limit. Like when you write it down, say y equal to, for example, y equal to ax plus c, you know right away this is what linear or straight linear function. If you say like it down power 2, then you know quadratic, blah, blah. At the same time, when we write the limit of function, this is the pattern of writing of the limit. Okay, So now we know the meaning of limit now, right? So before we go more example, right? I would like to everyone learn about property of limit first before we go the next one. Okay, now we go next one. Property of limit. So can I erase this one first? See now property of limit. Okay. The property of limit say if f and g are function and c, l, r, and m are numbers such that limit f of x equal to c equal to l and limit of g of x equal to c equal to m. So right now like I have two functions, function f of x and function g of x. Okay, so actually this one like operation of for operation of mathematics, they have like a plus, minus, time, and divide. And now this have one more, use the third square root. Can be cube root, how many third root, fourth root, okay, it's like in the pattern of thirds, okay? So now, then in this scene, the number one, limit function f plus function g of x when x equal to c equal to limit f of x plus g of x. Everyone see that how to write. And actually this one, you can do, that mean equal to this one. Maybe use another color. See this one. This one you can write it down as a limit. Okay, this one same as this one. Limit f of x when x approach to c plus limit g of x when x approach to c. The limit f of x approach to c equal to what? L, right? So you replace as L. Plus limit g of x when x, this is x, okay, approach to c equal to m. So you write m down. Okay, so then next, this the property of limit number one for the past side here. Now next, negative. Then the same pattern. Then this one we can expand become limit f of x when x approach to c minus limit g of x when x approach to c. Okay, so at the same time, if number three here for multiplication, so become limit f of x when x approach to c time limit g of x when x approach to c. Okay, and then number four. Okay, number four is a division. So this one equal to, you can write down it up in this way. Oh, okay, come back. Limit f of x equal to c, this one equal to L, right? So you write it down. This one become L times m. Because limit g of x equal to m here. Okay, now come this one division. So division this one, the limit f over g, f function f of x equal to limit f of x divided limit of g of x. So we're gonna have limit f of x when x approach to c divided by limit g of x when x approach to c. And this one gonna be L over m. And the last one just like in the pattern of search. So limit square root f of x equal to square root of L. That's all. The condition is what everyone should know. The root, any kind of root have to be what greater than 0, right? The square root for the even root was square root 4, 6 is root. Okay. Okay, then this is one. This is a property of limit. Okay, this is number 4. Okay, so I think I will stop right here and then we see you next class. after next class, I think are you are able to do some question. Okay, see you then. Bye.